All right, does everyone have these in their notes? Okay. So like I said, the hard part is not setting them up, it's simplifying. Okay, so what do these formulas do for us? Okay, let's think about it for a second. Cosine at 15 degrees, what does that equal? Without a calculator.
Square root of 3 over 2.
Can't cut your finger in half. That's 30.
Oh, 15.
Unfortunately, we can't. So, we can't find cosine of 15 degrees by looking at our unit circle using our left hand, any of that nature. However, we can come up with two angles on the unit circle that we are familiar with to find it. So if you think about it, 45 minus 30 is 15. So if I did cosine of 45 minus 30, I can find the exact value without a calculator using that formula. Okay, so we're going to do exactly that. So let's look at cosine of 15 degrees. We're going to make this cosine of 45 minus 30. All right, so that is our cosine of alpha minus beta formula. So we have cosine of alpha, which is going to be 45 in this case, cosine of beta, which is 30, plus sine of alpha, sine of beta. Okay, so cosine at 45 degrees is what?
2 over 2.
You can have your unit circle out if you need it. Cosine at 30 degrees.
Square root of 2.
Okay, sine at 45 gets us that root 2 over 2 again. And sine at 30 is 1/2. So when they tell you to find the exact value, they mean they want the simplest, radical, reduced, all the things, just not decimals. Okay, so we can multiply across. So the square root of 6 over 4 plus the square root of 2 over 4, which just makes it square root of 6 plus the square root of 2 over 4. And that's what they mean by exact value. Okay? So this is a little refresher to remind you that before the end of next week, which your test will be on Friday. I'll have you on Friday. I think that's right.
Wait, test on Friday next week? I'm not going to be here.
Before spring break.
I'm not going to be here. Yeah. I'm going to be in a car. So I can't take a test when I'm in a car. Trying.
And I'll just like to extend your breaks, don't you?
That's not my choice.
All right, so the next one, we have to come up with two numbers that add to get 5, but once we reduce them, it's stuff we're familiar with on the unit circle. Okay, so what I mean by that is, let's start off with the most obvious one. If we do 1 plus 4, then that gets me pi over 12, and then 4 pi over 12. 4 pi over 12 reduces to pi over 3, which I'm familiar with. But do y'all know anything about pi over 12?
No.
No. Okay, so then I think of some other numbers, all right? Well, what's 2 plus 3? Okay, that gets me 5. So then if I was to put that, 2 pi over 12 reduces to what?
5 or 6.
Are we familiar with that?
Yes.
Yep. And 3 pi over 12?
Pi over 4.
And we're familiar with that. Okay, so you have to think about ways to manipulate. Could we have subtracted 2 numbers? Yes. Is the whole unit circle up for grabs? Yes. Do I want to use the first quadrant? 100%. But there are other variations that y'all could come up with. So go ahead and use the formula for cosine of alpha plus beta and find the exact value. I'm so used to having these like sprawled out over the board, so I'm having to like squeeze them in here so it can be recorded. If you can't read something all right, let me know. The square root of 6 minus the square root of 2 over 4. Okay. Super important to know your unit circle, because the actual new thing you've learned today is, can you copy and paste a formula? Okay, the old stuff where you have to know your unit circle, multiplying, adding, subtracting, all the things of fractions, and of course they're going to get a little bit more involved than just the square roots of 6s and 2s and stuff like that as well. Any questions so far? All right, go ahead and try number 3. What two numbers did y'all choose to break up 7?
3 and 4.
3 and 4. It does not matter which one you wrote first. If you wrote 4 first or 3, it doesn't matter. It'll still turn out to be the same. All right, so if we break this apart, I'm going to do sine of pi over 4 plus pi over 3. That's why it's also very important to show your work here, that you're at least setting it up correctly. If you do make a mistake on knowing your unit circle or anything of that matter, I can at least give you majority of the credit here that you at least knew how to set this up. Okay? So sine at pi over 4, just making sure I did the right formula as I said that. We get our root 2 over 2. Cosine at pi over 3 gets us 1/2. We also have our root 2 over 2. And sine at pi over 3 gets me root 3 over 2. So we should get root 2 plus root 6 over 4. If you wrote it the other way, you would have had root 6 plus root 2 over 4.
Shouldn't that be minus? If they're plus and it's a sine one.
So the sine of alpha plus beta is a plus in between.
Yeah, it's a plus.
All right, so number 4. They're easier than what we've been doing, but they're harder because you want to make them harder than they are. What do they look like?
They look like this, the ones that we already did.
Yeah, it looks like what we've already done. It looks like this step right here. No, I'm not asking you to evaluate sine at pi over 12. No, I'm not asking you to evaluate cosine at 7 pi over 12. But if you can look at it backwards on your formulas that you wrote up at the top, what formula does that match?
Well, 8 pi over 24 would be pi over 3. Can you do that?
Well, just looking at your formulas, what is that match right there? Where you have sine of alpha, cosine beta, cosine alpha, sine beta.
Sine
minus
alpha minus beta.
Okay, according to our formulas, it is just like our sine alpha minus beta. So alpha in this case is pi over 12. Beta is 7 pi over 12. So whenever it's written in the expanded version of that, you're going to condense it to the, and you can tell I'm doing logarithms in my Algebra 2 classes right now. Expanding and condensing. We're going to take it down to that single trig function. So 1 minus 7 gets me a negative 6. What does that reduce to? And what is sine at negative pi over 2? Negative 1. Good. So when it's already written out in the form of the formula, you're just going to go backwards and evaluate that way. Okay. So that's dealing with the unit circle. we go out of the unit circle, we're going to be dealing with triangles. Okay. We're dealing with triangles anyways in the unit circle, but we never draw them. So when we are looking at something like this, which I have a typo. It's supposed to be beta. Definitely not going to find a beta symbol right now, but pretend that's beta. So when it's written this way, they want us to draw two separate triangles. Why is it two separate? Because we're dealing with an angle alpha and an angle beta. So they're not the same thing. All right, so they tell us that alpha is in between 0 and pi over 2. So that's that first quadrant. Sine is our opposite of our hypotenuse. We can do Pythagorean theorem, but what's our missing side?
4.
Then they tell us about beta. Beta is in between negative pi over 2 and 0. So we're down here in the fourth quadrant. And of course I didn't give myself some space over there. Let's try that again. And they tell us cosine, which is my adjacent to root pi over my hypotenuse. So go ahead and find your missing side. Since we are in the negatives for y, it's going to be a negative root 5. And that's how they get you. So on a multiple choice test, they will give that as an option where it's both positive and negative. So the reason why they're telling you where you're located is specifically for your minuses, basically. All right, your negatives. So then now we just follow the formulas and plug in the information we know. Okay? So sine of alpha plus beta. We are going to follow the sine of alpha, cosine beta, plus cosine alpha, sine beta. And we're just going to pull that information directly from those triangles we just drew. So sine of alpha, which they gave us, but if we looked at our triangle, it's 3/5. Cosine of beta, they have told us that one. But this is why we had to find our missing sides, because now we need to know what is cosine of alpha, and that's 4/5. And sine of beta is negative root 5 over 5. So that's why we need that other missing sides. So we get 6 root 5 over 25 minus 4 root 5 over 25. Can we combine those? Yeah. Those are those rules from our radicals stuff. So 6 minus 4 gets me 2 root 5 over 25. So when they tell you the location of the angle, that should trigger in your mind, I need to do triangles. Okay? Go ahead and do cosine alpha plus beta, sine alpha minus beta. All right, so cosine of alpha is going to give me 4/5. Cosine beta is going to get you that 2√5/5. Sine of alpha is going to get me 3/5. And sine of beta is that -√5/5. So I get 8 square root of 5 plus 3 square root of 5. Make sure I'm not losing my mind here. So I get 11 square root of 5 over 25. Okay, because I can multiply those coefficients out front. All right, and then for sine alpha minus beta, let me extend my page here. I get 3/5. Cosine of beta is 2√5/5. Cosine alpha is 4/5. And sine of beta is -√5/5. Okay, so that gets me 6√5 plus 4√5, which is 10√5 over 25, and that reduces to 2√5/5. Okay. So with tangent, this is when things get a little bit more involved with fractions and fractions inside of fractions and all the things, okay? So with tangent of alpha minus beta, try and make this as easy as possible on yourself. If you can reduce things before, do so. Well, let's go ahead and set that one up. Okay, so tangent of alpha is our opposite over our adjacent, so 3/4. And then to look at our tangent of beta, our opposite over our adjacent, we get -√5 over 2√5. So like I said, make it as easy as possible on yourself. What's something you can reduce first? Yeah, our √5s can cancel. Thank goodness, because we're going to have some that they're not. So this becomes a plus 1/2. And then go ahead and see if you can reduce that. I'm gonna change this one right here to automatically just do an 8/8. So now I get 5/4 divided by 5/8. And I write it this way only because it's easier for me to then do 5/4 times 8/5. So 8 divided by 4 is just 2. So again, super important you show your work so I can give you as much credit as possible. Questions so far? Besides elementary math, that's probably giving you the most issues. And that's not a mean way. That's where you learn it. Okay. Let's do some more of the tangent problems. Let's try number 7 up there.
What's the number?
In a minute. Hopefully that gives me more space now. All right, so alpha minus beta. So we have tangent of alpha minus tangent of beta. And 1 plus tangent of alpha tangent of beta. Okay? So 300 degrees, again, try to get as much of this out of your head as you can. I know that 300 degrees is going to be somewhere in that fourth quadrant, which always helps me know that it's going to be negative. I know that it's a 60-degree reference angle, so then tangent 60 degrees is root 3, so negative root 3. And 45 degrees, that's just a 1. So then I have 1 plus a negative root 3 times 1, which is just that negative root 3. So yes, rationalizing is still a thing. So if we have negative root 3 minus 1 over 1 minus root 3, to rationalize, we're going to multiply by 1 plus root 3. Remember, you just change the sign in the middle of the denominator. Double distribute both your numerator and your denominator, and then reduce from there. Some of y'all are working it out, so I'm going to work it out up here, but without talking through it. All right, so remember that last step, Dorito chip, if all three things are divisible by the same number. And notice how I don't include that radical, but -4, -2, -2 are all divisible by -2. So if you divide them all out, you get 2 plus root 3. Okay, so that's where they get more involved in regards to doing all of that. Okay, any questions on tangent so far? Besides it just having a lot of computation to it. All right, let's try the one that was below it, if you hadn't already done so. 19 pi over 12. Just leave this here, it's separate. Again, you might have done yours differently, so don't go erasing if you chose different things to add, subtract to get 19 pi over 12. Not only are we dealing with common denominators here, but we're also dealing with rationalizing all the things. Okay, so again, super important that we show our work. I'm going to go over here off to the side. And I can go ahead and change that -1 to -3 over 3. And this becomes a positive, but that makes it a negative. So I'm going to go ahead and make sure that, oops, not an 8. That's for sure. I'm going to say that's 3 over 3, and then minus our root 3 over 3. So common denominator, we can combine these now. So we get -3 3 minus root 3 over 3 divided by 3 minus root 3 over 3. Doing it that way just makes it easier for me to multiply by the reciprocal. Those 3's can cancel, but the others cannot. So now we have to rationalize. So I'm going to multiply by 3 plus root 3. Double distribute, combine my terms, all the things. Give myself some space to do that. What are they all divisible by? 6. So negative 2 minus root 3. We got it. Good. It's a process.
You made it a lot harder than I would do. Yours is so a lot harder.
Yeah, yours is.
How so?
I don't know. There
I
was
did,
just more
I
practice,
did
a lot
5 over
more.
3 and 5 pi over 4.
That's what I did.
And then, like, you just did what you got more.
Yeah, it was like the last one, except
cool.
a little different.
Who knew? Did you have a question or were you gonna?
Yeah, I don't know. So I got 2 plus radical 3, but I don't know what I did with the signs. I mean,
Wouldn't that be? I'd have to work through it too to figure out where you missed your negative. It could have been. Three. That is in the third quadrant, really positive. Yeah, I have to look through it. Funny, which ones did y'all choose? 5 pi over 4 and what?
5 over 3.
Good to know. All right. Let's see. Other than that, I think that's just more going backwards. So I think we're okay to stop there.